Okay, welcome back from spring break. Hopefully you're not watching this as I'm posting it on Saturday evening. Take your last 2 days or so. Excuse me, day and a half. And enjoy. We're probably not going to be able to get through 11.6 because at least one of these problems is going to be pretty long. But I'm gonna do as many problems as I can to kind of just get us back in the mindset of some systems of equations and matrices. Excuse me, and we'll go from there. Okay, so this is for Monday. The word problems in 11.1. 11.1 was a review of Algebra 1 and Algebra 2 systems. The word problems, we pretty much did many of them. When back in the day when we were able to like sit in a classroom together. I don't know if you guys remember that as fondly as I do, but so 57 is an easier problem. I'm just going to set it up to keep things short because solving it is pretty easy and I'd rather focus on the other stuff. I'll read it to you real fast. What I was going to say was, though, review those word problems that we already went over in class because it's been quite a long time. All right, in 2005, there was a total of 55 commercial and non-commercial orbital launches worldwide. In addition, the number of non-commercial orbital launches was one more than twice the number of commercial orbital launches. Determine the number of commercial and non-commercial orbital launches in 2005. So that last sentence, that statement of the question, whether it be stated as a statement or a question, always tells you how to define your variables. And please make sure you're defining your variables. Number of commercial orbital launches. So many words. Oh my goodness. Number of non-commercial orbital launches. So make sure you do that for all of your word problems. Read that sentence that's telling you what it's asking and define the variables appropriately. Now it says there was a total of 55 between the two different types. We all know what that means. And it says that the number of non-commercial orbital launches was, so we know was is a tense of is, so that means equals, one more than twice the number of commercial launches. Okay, so we're just going to substitute that in and solve and find the number of each of the different types of launches. All right, baby steps. This one's going to be the long one. 11.2, number 49, was solving systems by using matrices, getting the matrix into reduced to echelon form. So, pretend you didn't hear that. Got all kinds of beeping and messages happening. Slightly distracting environment. I apologize. Okay. We're going to write the augmented matrix. Augmented means it's got the answer column. So make sure you're paying attention to the vocabulary. Let me just make sure I got that right. Okay, I'm going to switch to pencil because I don't want to make a mistake and have to scribble. Okay, so this makes me happy. I don't know if that's going to stay, but if it does, that'll really make me happy. Remember, goal number 1 is the top left corner is a 1 that's already taken or already done for us, and then we want to get zeros. So we're going to make a new row 2, and it's going to be, I want to get this to be a 0, so I need to do -2 times row 1 plus row 2. So -2 plus that. -2, so this is going to be 4 plus that. -2, so that's going to be -6 plus that. Let me double check that one. -2, so -6 plus 1, -5. -2, so that's going to be -14 plus that. I'm going to double check that one. -2, -2, 4, 5, -2, -6, -5, -2, -14. Yeah, okay. And then we're going to do, we want this to be 0, so I'm going to do 3 times that plus the old row 3. So 3 times that, 3 times that, that's -6, right? 3 times that, that's 9 minus 2. 3 times that, that's 21 minus 10. And let me just check. Okay. And then I want to get, so we could do the ones in the top and then the zeros. And then we go along the diagonal, we get the next one. So we're going to make a new row 2 by multiplying by 1/5. So 1/5. Okay. Excuse me. And then we're going to carry on with the zeros above and below. So row 1, I need to do 2 times row 2 plus the old row 1 to get that to be a 0. Remember the way that we do these, the focusing on the order, the 1 and then the zeros and then the 1 and then the zeros, it makes sure that we don't mess up any of our previous work. So 2 times this plus this, 2 times this plus this, 2 times this, -2, plus this, 2 times this, -4, plus this. And then my row 3, I'm going to have to do 4 times that, plus that, right? So 4 times row 2 plus the old row 3. 4 times that plus that. 4 times that, -4, plus that. 4 times that, -8, plus that. Okay, let me just double check that. Okay, that looks good. And then I have ones and zeros. I have 1 and zeros. I need to get that to be a 1. So my new row 3 is going to be 1/3 my old row 3. Almost feels like a waste to write another matrix for this, but you gotta do what you gotta do. Okay. And then I need to get the zeros above, and then I'm going to be done. And those are actually going to be easy. So for my new row 1, I'm going to do what? -1 times row 3 plus the old row 1. I'm always using the 1. Oops, you can't see that. Sorry. Oh, darn it. I'm always using the 1 from that I just worked so hard to get the other things to be zeros. Let me move this down a little because you can't see it. Okay, so the new row 1 is going to be negative row 3 plus row 1. So all of this stuff is going to stay the same. I'm going to do a negative times this plus this. Negative times this plus this. Okay. And then my new row 2 is going to just be row 3 plus row 2. These will make 0. So when I add all of these together, that's going to be 0. That's going to be -1. And I'm not doing anything to this. So I can see x plus 0y plus 0z equals 2. Y equals -1. And z equals 1. Remember, I want you to write your answers like that. Okay? All right, we're at 9 minutes, so let's see what we can do. Real quick review of Cramer's rule. So if I have a system, I'll show you for a 2x2. Just a refresher. What did we do? See, this may not match exactly what you have in your notes. I'm just kind of winging it. The x coordinate is the d sub x over d, and the y coordinate is the d sub y over d. The D is just the discriminant of the coefficients, the denominator of both of those. The D sub x, remember we take the x column and replace it with the answers. So instead of the AC, we have the RS, but the BD stays. Okay, so we're basically taking this and putting it right there. And for the dy, we're taking this and putting it in the y column. So the x column stays the same, and the y column becomes rs. And just in case you forgot, I don't think you did, but just in case you forgot how to do a discriminant, remember we do crisscross with a minus in between. Okay, crisscross with a minus in between, and so on. Okay, Cramer's rule, that's what we did in 11.3. 11.4, number 29 was what I had planned on doing next. Let me see. Oh yeah, that's a multiplication problem. So I think we can finish through 11.4 without going over 15 minutes. 11.4, number 29. This is 11.3, by the way, the Cramer's rule stuff. Okay. Okay, 11.4, number 29, tells me to multiply. I'm going to be extra cautious and like triple check what's going on here. Make sure I'm writing it down. That's an 8. Okay, I'm just going to triple check. Number 29, I want to make sure I didn't look at like 2 different problems as I was copying. Okay, so that's right. All right. Remember that when we're multiplying matrices, we write the first matrix however many times there are columns in the second matrix. So there's 1, 2 columns. I'm going to write this matrix twice, and I'm going to give myself lots of space. So there's the first one. Nice generous space in between. There's the second one. And then I take the column 1, 6, 8, and instead of going vertically, I'm going to go horizontally 1, 6, 8. So I've, remember, spun it on its side. So the 1 is here, the 6 and the 8. Now I'm going 1, 6, 8. Okay, and that carries straight down. And I do plus everywhere in between. And then I'm going to do the same thing with the 3, 2, negative 1. 3, 2, negative 1 instead. Right? And then that carries straight down. And I do pluses in between. Remember, don't put pluses in between here. We want to have 2 separate instances of this happening. Okay, and then I'm just going to do the arithmetic. Hopefully I don't make a mistake on the arithmetic, but you know me. What is this? 1 plus 8. 2 plus 24, so 26 plus 8 is what? 34. 3, that's 36, so 39, so 47. 3 minus 1. 6 plus 8 is 14 minus 1. 9 plus 12, so 21 minus 1. I could check that, but yeah, we wouldn't have time to do another problem anyways, so let me just check this. This was 11.4. I'll check my old work for this. Number 29. 9, 34, 47, 2. Yay, I didn't make a mistake. Okay, and then remember one last thing. The size of the matrices, row, column, RC. This is 3 by 3. Row, yeah, how many rows does this have? 1, 2, 3. By columns, 2. Rows go this way, columns go that way. The middle number has to match, and it does, right? And when the middle number matches, the outer numbers tell me the size of the answer. 3 rows, 1, 2, 3. 2 columns, 1, 2. So that's a good way to check yourself. Wow, it's just at 15 minutes any second now. All right, so I'm going to post this with some review work. And I will have a new section for you guys for Tuesday, I believe.